All right, so this is our team over at the DSI. So we have a number of staff data scientists, and we are sort of like a professional data science team, which is embedded in the university. And also we have a number of postdocs. Our postdocs, as noted here, they come from certain backgrounds, but several of them actually are generalists. So they might have done their postdoc, for example, in astrophysics, but what they want to do is more generally apply the AI tools that they learn and that they continue learning to different fields in the university. And as you can see, that, I mean, that has high alignment with what we do at the DSI. And also, again, we're having this interdisciplinary mixture of people on teams. So whenever I talk about the projects, some of these people, one or more of these people have all been involved on the project. So I'm not presenting this like I, Charreau Bell, have done every single one of these things. No, it is all a team effort. I just think of me as the presenter, some of the things I have personally run, but it really is all of us together that are making this a good thing for our university. Okay. So now I want to tell you a little bit more about some of the projects that we have done, particularly in the context of the incredible acceleration of technology when it comes to AI and machine learning, particularly AI and deep learning and generative AI. And so I started at the Data Science Institute a year after it was created, so in 2019. And we began running projects around that time, maybe a little earlier before I got there. And so two of the projects that we started off with when I got there were with some researchers studying despair, Dr. Lauren Gaydosh. She had this really big set of data. You hear big data, you think machine learning. And so that's exactly where we went with it. At the time, the technology was, I mean, what was exciting in the technology was this notion of auto ML, and you might not have to do like all of this handwritten coding in order to get a solution and get a great model. That was all the rage at that time. Also, Tidyverse had been created like, I guess, unleashed a couple of years before. Did I say Tidyverse? Yeah, Tidyverse had been released a couple of years before. And while we were in the midst of that project, and our Tidyverse would come out for modeling, which is called Tidy Models, and it was really powerful within our framework. So at that time, we were very interested in generating these predictive models to help understand the contributors to despair and try to figure out ways that they could be mitigated. But that was the technology that we were working with at the time, like amazing technology. Another project that we were working on was sort of in a different realm. It was in the natural language processing realm where we were talking about law documents. And this researcher was really interested in extracting information from these lawsuits. So, who the judge was, what the district was, what kind of court it was, the jurisdiction, all that great stuff. Wanting to pull all of that information out of a huge corpus of lawsuits that he had aggregated over time. And so that was a huge task. One of the things about the data set that we were using was, one, it was huge. Two, they were PDFs. Some of them were not machine readable PDFs, but which ones were the machine readable ones? Something to learn when your code errors out. So those are some of the things that we were exploring with that. If you've worked with PDFs before or NLP documents, you know that sometimes some of the packages that we use, like they appear to be successful in reading the PDFs, but then when you go and look at the actual representation, it just looks crazy. And so it was just a really interesting time of trying to do NLP at that time. So the year before, a deep learning approach called ULM Fit had just been released for NLP. So at that time, pre-trained models and transfer learning were, I mean, that was like the focus of everything, but the way that it was applied was particularly to vision. And so Jeremy Howard and his team, they looked into and determined and created a way that you could use that same premise of transfer learning and pre-trained models on NLP. And so we jumped into this project. That's straight what we went to. We went to ULM Fit. We did do machine learning and traditional NLP, but that was our major powerhouse that we were going to use, ULM Fit. With that, there were still yet challenges. for the time that we knew what was going on in NLP with ULM Fit, it was a great solution. We were able to do that transfer learning because of the platforms that had been created at that time. We were able to make significant strides there in that work. If this same thing had happened today, we might have seen something a little bit different, but still the technology there was very powerful for us. As you may recall, thinking back in those days, GPT-2 had just been created, and it was just just groundbreaking. The thing about GPT-2 though was that it was maybe not the nicest model. It would really just say kind of anything to you. It would be rude, it would be coarse, whatever came out of its, little artificial mouth it could just really be anything. So as you know, we've made it a long way from that, but at the time, GPT-2 was amazing. One other piece of technology that was, life-changing is the Hugging Face Transformers library. If you don't know about it and you do anything like deep learning, that is a library that you want to run to and look at right now. It's amazing. And what it provided at the time was this model, essentially like a model zoo, where you're able to access lots of different kinds of models without having to download the weights, with all this rigmarole that was really error prone. You don't have to write the actual PyTorch. You had this library that helped you to do the training of these models and to access the weights in a really good unified way. And people were putting their models on there. Like there was a BERT model on there that was easy to access. After Roberta was created, that was put on there that was easy to access. And because of that, that's where we also focused. So we started with ULM Fit. During the time that we were working with ULM Fit, the Transformers library came out. And so we started like aggregating all of those things to try some of those models. So one of the things that we ended up trying was Roberta. Even the progression from ULM Fit and Roberta had a significant impact on the performance of those models. So just thinking about that, it's just amazing to see like over just like a couple of months in a single year, how the technology can progress so much that you can see a definitive difference between just two types of very related technology, but that are distinct. So that was our lovely 2019. In 2020, we saw a lot of big new models in our field. So one, we saw GPT-3. We know GPT-3 pretty well because at the current time, we use something called GPT 3.5 if you work with OpenAI software. And so we know about GPT-3. It was, again, groundbreaking, very powerful, a little bit nicer, more, appropriate for society. At the same time, another very large language model was produced called T5. And T5 was extremely interesting in the way that they trained it. The way that they trained it influenced the way that we train things now with this sort of string-based in and out output. So in other words, whenever we had been training something like BERT or Roberta, we would think of the inputs as the NLP and the output as being like a class or some section of text. With T5, we began to think about the inputs and outputs both as text. So instead of having a classification like a number coming out of the model, we might instead have it saying in words that the output of this classification model is like 5 or something. So it was actual string. And so even when you think about that in 2020, how revolutionary that idea was and how it's influenced what we have today, remarkable. Also during that time, very exciting things came out in audio as well. So again, there had been a lot of focus with transformer models on NLP, but then the Wave to Vec model came out. It worked on audio. It had the same sort of conceptual premise as BERT, meaning that it was really made to be an encoder model, meaning that it was meant to like understand audio. Groundbreaking. Also, again, related to T5, there was this notion of task-based training where instead of having like classification very specifically, the tasks were generalized to string in and string out. And again, that is highly influential about how we do things today. In that 2020 period, we were working on a few projects which were influenced by what we did and did not have access to at the time. And so one of these projects was with some researchers in the humanities that were studying the slave society's digital archive and trying to convert that into a form that actually would be conducive to analysis. So what that data set looks like is it is a lot of images. So images of these pages like you're seeing here. So this is with the image that like each page has an image of it. And on that page is essentially a log in ecclesiastical, like Portuguese, French, way back in the day about the births, deaths, any kind of records that a church would keep relevant specifically to enslaved people. And so by looking at that, what they hope to achieve in the end was to be able to build these family trees of these enslaved people by looking at this huge corpus of text and historical record. So I'm sure you can see some of the challenges there. There was this need to extract information from the images. Even today, that's actually pretty difficult. So extract information from these images in a language that is not really written in that way anymore, and with the kind of handwriting that they had and were writing with in that time. So currently today, that might be a project that we might be able to undertake really successfully. But at the time, in incremental research, as we all love to do, there were already some transcriptions that were available. And so where we went there is with machine learning models to help them do a sort of natural or named entity recognition task. So one of the things about trying to figure out people in a family tree is you have to identify the people in the text. So what better than a named entity recognition task? And that's exactly what we did in this project. That ended up being extremely, extremely successful. Thinking about the fact that we also were using transformer models that had these sorts of common sorts of architecture. They're not the huge billion parameter models that we have today, but things that are more like a BERT or a Roberta, larger, but definitely not one of our, what I'd like to call XLLMs. So extra large LLMs, like OpenAI's GPTs. So that was a very interesting task. Again, influenced by what was not possible with the technology at the time for their objective. Another project that we had at that time, also completely appropriate for the time, but greatly influenced by the technology that we had available, was a project that we had to study factors influencing teacher retention or attrition. And so what that means is in a school system, there might be factors that cause teachers to leave, certain types of teachers to leave, people with certain backgrounds. What are those factors? And if you're experienced with R and Python, your brain might go straight to R. R is a great computational platform for when you're using like statistics or you want to do like data analysis, data cleaning, data like manipulation. R is fantastic, particularly if you're using the tidyverse and tidy models. At that is the year that tidy models came out, which was absolutely outstanding. The way that they had chosen to implement tidy models in the standardized sort of framework made it extremely conducive to us creating reproducible and understandable to our collaborators predictive models of what was leading to teacher retention. Also, with that implementation of tidy models, it allowed us to better demonstrate some of the outcomes, which might be a little bit unfamiliar. So I think in data science and artificial intelligence, we tend to think, oh, AUC, we're thinking confusion matrices. Other people look at those things and are like, well, that's a picture there. And so with tidy models, even the way that they did their documentation, the way that they had things configured in tidy models, it made it very conducive for our collaborators to understand what the outcomes and the meaning of this work was. Something that I learned from this project in particular with teacher retention is the collaborators, the domain experts, they are essential for any given project. In the way that we work at our Data Science Institute, we have the collaborators meet every single week with the whole project team. And that is because they have the expertise to be able to assess the outcomes in a way that is meaningful in their field. So let's say that we had a finding that was pointing to, I don't know, something that they know in their field is like discriminative, or that they know is usually influenced by da da da. They are the ones that can actually look at these outcomes and comment on them and suggest what other pathways need to be kind of explored in the data, because they know sort of what's going on. And so I thought that was so powerful when I was on this project. Just the knowledge of our collaborators and the brilliance in their essential place on project teams. So after that, there were always collaborators on my project teams. They got to be there every time. Can't do it without them. Love our collaborators and our domain experts. So again, here we are in 2020. We have things like Wave2Vec, we have GPT-3. We don't have GPT-3 chat, but we have GPT-3 like sentence completion or completion, meaning that it just kind of continues on with whatever you started saying, but you can't like ask it questions very long. So having looked into those types of things, using tidy models with R, not being able to completely make it to the end of our task in slave society's digital archives because of technology, but being able to start down the pathway. In 2021, that was the continuation of a very interesting time. So as you may recall, in 2021, that is when DALL-E, which is a model that generates images, that was released by OpenAI. And so that again was groundbreaking for people to see like these models that are able to like from text generate images. Also during that time, the notion of prompt design became very notable, meaning that you have to like based on the task that you want to do, you have to formulate the inputs and outputs. So like T5, but it is also interesting and important, and an idea that came from that one should also mix those things together. And the more that you put the different tasks together and you phrase things in a way that is making sense, then you end up with the kind of models that we have today. Also, during this time, a model called VI2 was released. So it's a transformer model again, but it is a vision transformer. And again, groundbreaking for being able to predict things about images and really laid the foundation for the way that we do, the way that we do image processing with transformers now. Also, there was a piece of technology called Haystack. So if you use ChatGPT, if you use like Bard, Claude, there is this ability to upload like text, like you can upload like your PDF or what have you. And it will sometimes try to do something called retrieval augmented generation, where it is looking at chunks of your text if it's too large, chunks of your text to understand what it should be looking at to answer your question. So let's say you have a question about your document, maybe you uploaded a syllabus and you're like, what day is my third assignment due? So if it needed to like parse that into chunks, it would figure out which one of those chunks is most relevant. It would pull it out, put it into the context, and then use that to answer your question. One of the first platforms to do that was called Haystack, and it came out in 2021. And this is when we really began to feel the motion of technology. So if you recall, earlier, back in 2019, we had the project with the legal documents. And the point of it was to find out information, little needles in the haystack from those documents. And that is when we began to realize like the way technology moves, had we had haystack like in those times, like the result may have been just so much different. And just the power of this set of models. And in fact, we were so curious about it that we did go back and implement that project with Haystack. And it was exactly what we thought. With retrieval augmented generation and that kind of technology, it is so effective in working with those legal documents to get the kind of outcomes that we were after. So with the introduction of that technology, alongside that, we were working on, again, several different types of projects, most of which at that time were focused on natural language processing. So one of them, which will come up again, will be this first project. And it is about understanding ancient civilizations and essentially their city layouts. It's an anthropology focused task. However, the person that we're working with, an archaeologist, he goes and he collects samples from different historical eras. And so what he's doing is he's collecting these soil samples because he's trying to understand the location of where ancient stone tools were made. And the reason that that is important is it influences the layout or the belief about the layout of the entire city around this industry. So he goes and he takes these samples, and what he needs to do is identify the small particles that are in the soil that are called lithic microdebitage. And what those are just these offcasts of stone making tools, right? So he's looking for, again, these little needles in the haystack. Now, thinking about soil, I'm sure you can imagine that if you went and you tried to classify every grain of like soil that you had collected, even in a single handful, if you looked at each and every single one under a microscope, that would take you an actual eternity to complete, one full eternity. And so with the kind of ideas that he had, he thought, well, let me go, buy a particle analyzer, and then I can put all these soil samples into this particle analyzer. Not only will it take pictures of the particles, multiple pictures of every single particle, but it will also output a tabular representation of all the measurements about each particle. And so immediately when he thought about this, he was like, this lends itself really well to data science, because if I have this tabular data set and I have some data which is already labeled, that means that I can put these things together and build a predictive model that, based on the outputs of this particle analyzer, it can predict for me which particles are lithic microdebitage and which are not. Meaning that he's able to understand the soil composition without spending the rest of his life looking into a microscope trying to count lithic microdebitage. This was a great approach that he decided to take. And of course, we worked together to build this predictive model. Again, we had just stood on the shoulders of giants because we had tidy models available to us. We had to do a lot of data cleaning, a lot of modeling, and tidy models is just fantastic for all of those things together. And again, highly understandable for collaborators. The other projects really focused around NLP. And so again, we had access to these transformer architectures, a streamlined way of accessing models and sharing those models, a streamlined way of training models. And so we were able to really work a lot in the area of natural language processing, accelerated by these types of things. So some of the things that we worked on were things like understanding and predicting outcomes of meningioma based on the surgical notes from surgeons. Also, we were able to understand some of the context around negotiations, we were able to begin this project looking at the context of negotiations, how we might classify the individual components of a negotiation. Also, we had a really riveting project with one of our associate provosts, I think he is now. And he has a whole project called Lost in the Ivy. What he has done is he has gone and he has interviewed like pretty much all of the Black students since we were able to be accepted at Vanderbilt. And what he was trying to determine is the trajectory of experience. Are there any underlying themes about these experiences? And if so, how have they changed over time? Interesting. This also lends itself to NLP, of course, but the question being what kind of NLP, because at the time, thematic analysis was still a little bit hard. Like the way that people were approaching it was still not really through transformers, but with traditional techniques like LDA. And so that is what we did. However, there was a component of the project that in the interviews that he did, he asked students or asked all of the members of the community at the time certain questions about themselves that were standardized across all of the interviews. So, where are you from? What do your parents do? What kind of activities were you involved in on campus while you were on campus? And those sorts of questions. But at the time, there was no structured data that had all of that information. So if he wanted to know how many of the people that I've interviewed went to a certain kind of school, like to a private school, or how many went to public school. That is not something that he would be able to answer easily without maybe hiring someone to go through every single interview and pull out this information. But again, we're standing on the shoulders of giants. We have access to things like transformers. As we said in the previous slide, we have a different way of extracting information from text. And so we use that transformers library, and we use extractive question answering on these texts. And we're able to ask questions like, where is this person from? What did their parents do? And with that, we were able to extract information from the interviews and then format it into this tabular data set, which he was then actually able to analyze. And when you think about that, the kind of impact that that can have on qualitative data analysis, how many researchers have just hordes of interviews, they have videos, they have audio. When you think about that, the ability to also turn that into something that can have a tabular form, amazing. It's amazing. And it really was truly what this slide says, a new discovery and just a new pathway for our qualitative researchers to understand the research, or better understand the kinds of insights that they can draw from the data that they have. Very interesting times. Okay, so we are doing lots of work in NLP. We are still, there are still some limitations that we have, but we are seeing the ability to do different kinds of tasks that were previously extremely hard. We're seeing them more and more being able to be streamlined by these differences in technology as we go along. So this was the year 2022 where things started to really get crazy. But as we know, 2023 last year was just a whirlwind. So coming back to 2022, we had started these projects that were really, again, beginning to leverage more of the underlying technology for transformers. So what do I mean by that? Well, again, we have qualitative researchers that were looking for ways to better understand how teachers teach in classrooms. So there are formal sort of assessment mechanisms, which they have. And so if they could just, do that automatically, not that that would be the replacement for the actual person that comes in the classroom and does the assessment, but would allow teachers to have real-time feedback in their classrooms in preparation for this assessment, that would be a really powerful thing. And so these researchers, they decided that that was something that they were going to undertake. What they had was these recordings of classroom audio. It's private data, of course, because it has recordings of children speaking, but it has a lot of recording of the teachers talking. And so with that, what we could do is if we can extract out the pieces of the teachers talking, and then apply a label to those based on the knowledge in their field and their tradition in their field, we can build a predictive model based on some utterance of speech by the teacher, what kind of assessment would the assessor give that? So the kinds of labels that we had were things like praise, like that was a praise statement. You did great, Jimmy. Or reprimand, Jimmy, you need to sit down, you need to do it now. Or opportunity to respond, which is, what do you all think about the last bit of the lesson? So those were our types of labels that we had. And again, we just talked about how Wave2Vec had been recently introduced. And so with that, we have the ability to put raw audio into this transformer, and then out of it, get this representation in this standardized audio space. And so with that, we were able to generate these embeddings, and then we'll be able to use those to actually do the classification. This, again, was a really interesting application of some of the technology that was available. With our Wave2Vec takes a particular approach in the way that they do their implementation. And so just based on the technology that was available, Wave2Vec 2, we were able to find some pretty rock solid predictors. Maybe not rock solid, maybe that was the next year. But no, that was this year. So with that, we had implemented Wave2Vec 2. But in 2022, OpenAI released Whisper. Whisper has a different architecture from Wave2Vec 2. they take two like almost completely different approaches to how they train the models. And so with that, we had already implemented Wave to Vec 2 because it was available. When Whisper came on the scene and was available for us to use, we took that part of the model that we were able to use, and the difference between Wave to Vec and Whisper was, again, just this night and day sort of comparison. And it was just so interesting to see how, when we were thinking that maybe it wouldn't be possible because, maybe the audio wasn't, as clear as it could be, or maybe there wasn't enough signal in the audio to be able to discern between these classes, just a slightly different approach to understanding audio through Whisper allowed us to have substantially better results. Even with that, with the release of these audio models, there are other types of audio models that are really helpful for qualitative researchers who have audio and have recordings. And some of these are based on transformers. So one of them, which may be based on transformers now, is called Pianote. I call it Pianote because Python anote, but it's supposed to be called Pianote. What it is this platform for automatic segmentation and other types of things. So in another project that was related, because collaboration building, they had recordings of teachers in classrooms, but what they were trying to label was the kinds of statements in terms of executive function. So some of the statements that the teachers would make would be one type of statement related to executive function, helping students to perform some sort of task. But then other statements would be either a different kind of executive function statement or other types of statements. And so again, they wanted to take a similar approach in terms of being able to classify the types of executive function talk that were in the classroom. They had an additional issue, which is that they had just full audio of the entire recording. It wasn't pre-labeled to some extent. And so the first thing that they needed to do was just to be able to segment the audio into relevant pieces. Again, technology to the rescue, where previously this would have been very hard, still hard. If it would have been very hard though, and very expensive or time consuming, or both, we were able to utilize this platform called Pianote, which does one, speaker diarization. It's open source, meaning that if the teachers are talking and then the students are talking, we can separate those two types of speech. So now we have the teacher alone, which is what we're after. Pianote will also do voice activity detection, meaning that when the teacher stops talking in their track, the audio will be segmented out for the periods that they are talking. So just the introduction of these new pieces of technology really were able to accelerate the kind and enrich the kind of research that we were able to do. But not even we, the qualitative researchers were really able to take this on their own. Once we had worked together, understanding things like Whisper, what a transformer is, ways to write Python, platforms to use, they were able to really take this and on their own, just move it forward. And again, that's one of our entire goals. Data science is AI belongs to everyone. And it's just this amazing thought that especially as we go on with technology, it will more and more be in the hands of the domain experts who will be able to very well understand what it is they're doing in the analysis and the meaning of it as they're going along. So that is just one of the projects that we did in 2022. But again, we had a lot of different ways of applying the previous technology in 2021 alongside some new initiatives. So in this year, we were able to look into how to build new training technologies so that students or anyone is able to better learn new languages. If you've learned a new language before, you might recall like opening up a textbook and learning like the most basic statements that you would never use in conversation, maybe once in like every 2 years. But with this approach, the researcher was really interested in people being conversant on topics that are relevant. So what he wanted to do was to leverage corpuses of like newspapers. So if the person wanted to be conversant maybe on climate change, they could study words based on the information that the model had pulled out of these climate documents or these news articles. Ancient mortars, you might have just seen that picture in the last slide, right? So as we said before, with the movement and the just change in technology, he had images of each and every single particle. And so now that we have made it from this really great model that is able to predict outcomes based on tabular data, it's time to move on to the image data. And so without even needing to do that, the tabular component, which comes from the images, we could go to the source and build an image-based model, which does the same classification, but utilizes something like BIT or other image types of transformers. So again, with the motion and the evolution of technology, we are evolving some of the ways that we can approach the solutions that we generate for research. Assistive technologies, that was part of our summer Data Science for Social Good program, where we worked with neurodivergent populations to create technologies with them that would benefit them. And again, this is such a powerful area when we're able to come together with people who are knowledgeable in the domains, and they're also able to participate in the solutions that they are generating. This is another really important component of AI models, machine learning, generative AI, where whenever we're developing models, we should always be thinking about and involving the people and the populations who it will impact, because of course they will know and understand or be able to generate concerns, statements, ideas around the kind of technology that will impact them. 2023, last year was nuts, was it not? So in terms of technology, we saw just tons of everything. So I think the year started with ChatGPT 3.5, maybe Turbo. And then after that, we saw something like Claude. Claude has a longer context, meaning that instead of being able to put in shorter documents, you can put in lots of documents at the same time directly into the context so that it is able to compute based on all of that information that you put in. Wow. So if you recall, we had a project that was about negotiation, doing these classifications on these different documents. A way to approach that is to put all of the documents and some labeling into something with really long context, and then have it do that labeling. And with the advent and the introduction of Claude 100K, that became a possibility. And it was very performant as well, but it was an option that was not previously available to us. But it was when it was very impactful. In 2023, we also saw Code Interpreter, which is like a sort of tool with OpenAI, essentially, like instead of just generating code, because now that's not good enough for us. Now with Code Interpreter, it is also able to generate the code, assess the code, fix the code, and then generate and provide you back the code at the same time. So with the advent of that just changed the face of education in particular, especially for people who are teaching things like programming classes, such as myself. And so it just, the power of that particular platform cannot go overstated. So if you remember at the very beginning of this presentation, we were talking about the tabular data that came out of that archaeologist's particle analyzer. It was tabular. Imagine that you can upload that data to Code Interpreter, which you can, and it can do an entire analysis, which it can. It can give you the code to generate a model, which it can. Imagine that you did that. So at the beginning of this presentation, you saw one of the team members, the chief data scientist at the DSI, Jesse Spencer-Smith, and he thought to himself, I just wonder how good Code Interpreter is. And so he did take that data, he did upload it to Code Interpreter, it did do an entire analysis, and it was really good. So that's the way technology is moving along, and just so quickly, very powerful technology. So again, although we never should completely put responsibility directly on the AI, this is collective intelligence, meaning that we also need to participate. The thing about it is that had that technology been in the hands of our collaborator from the beginning, he might have been able to accelerate that development process. But even if the technology had been in the team's hands, we most certainly would have been able to accelerate that development process. Even beyond the code interpreter, we also had the introduction of AI assistants. Something interesting that we had been doing during 2023 was trying to develop these platforms that would help students to do their own sort of learning. So let's say, for example, a student was maybe having trouble understanding some programming concept or something in business, something in econ, but they had access to an open access textbook. What if they were to just upload that textbook and then ask questions against it with a really good model? And that was something that we were wanting to develop. And by the end of the year, OpenAI implemented these OpenAI assistants where it's just a user interface where you're able to do that exact same thing. Also, they introduced these multimodal models where, let's say, for example, you have these handwritten images. So like me, I like to take handwritten notes. Maybe you want to ask questions about those notes, or like Slave Society Digital Archives that we have pictures of their entire records. Maybe we want to upload that to ChatGPT and then ask it to transcribe for us or ask questions against it. Totally possible now. We also saw the advent of things like Bing GPT search. So now we have GPT-powered search engines and also things that can help us with the coding, like GitHub Copilot. So with that amazing year, I think that we were able to also get into some really interesting areas. We also were able to more focus on, or maybe not focus, but look into the technology a little bit more. And so now we're developing new models for things like gravitational waves, foundational models, developing models that are, again, helping with the development and analysis of speech in children in different ways. And so with the technology, I think something that we can see is that as we go further along with technology and AI, the power of the analysis is becoming more and more in the hands of the researchers, and the sophistication of the analysis that is possible, again, is very much in their hands. And so I am very excited about this. I am so excited to see the kind of innovation and discovery that we're going to experience as a society. And I mean, I think it's just really going to be amazing so long as we wield this technology responsibly. So I think I've taken a little bit too much of your time today. I think 2 extra minutes, but thank you so much for your time today. Like, please feel free to ask me any questions that you have. And thank you for your time.